Hello, everyone. I think this is my maybe seventh day of trying to teach myself C++. And I think today I want to kind of think of a project that will put together everything that I've been learning so far. So if we go through most of the stuff that I've learned about variables and types, control flow, which is like if statements, and then some loops. I learned a bit about pointers and a little bit about manual memory management and also classes and structs. Or maybe I haven't gone through structs, but I kind of learned a little bit offline. One thing I haven't talked about much is the destructor, which I think we can also go over today. Um, but I think one thing I thought of was implement a linked list. If you guys don't know what a linked list is, I can quickly explain it, but I think this will be a pretty good practice problem for me to basically put together everything I've learned so far. So yeah, maybe I can try and draw what a linked list is. So a linked list, everyone's maybe least favorite data structure, but yeah, a linked list is a data structure. It's different from an array. An array is contiguous memory, and there's data stored contiguously. Basically, there's no space between the memory addresses. But a linked list is a data structure that allows you to store data. And what is required in every linked list is it's basically made up of nodes. And each node has two properties. And I'm talking about a singly linked list, not a doubly linked list. Each node has a value or some data that you want to store. And it also has a pointer to the next node in your list. So conceptually, what this looks like is I can store some values in this node, like let's call it an integer, like the number 2. And this node also stores a pointer to the next node in our list. So let's say I had a list that was 2, 3, 4. We would have 3 nodes, and each of them would have this pointer pointing to the next node. So this is an ordered data structure. And if you like traverse this linked list, you would get the nodes in the order 2, 3, and 4. And one last thing to note is the final node in your list always points to like null. Depending on your language, you could call it null pointer or none or something else in other languages. Also, the first item in the list is usually referred to as the head, and I think the last item we could call the tail. So yeah, I believe that this is a pretty good project to practice the stuff that I was talking about earlier. So let's try and implement this in C++. Let's make a new directory, and let's call it linked list. And we can cd into it, and let's make a file called linkedlist.cpp, and we can open it up. Also, thanks to one of my viewers that told me a couple of terminal shortcuts or commands, like I think Control L is to clear. So that's super helpful. I'll be trying to learn some of those commands. But yeah, let's start off with our linked list implementation. So I think we will, as always, include iostream so we can print. And I think that might be all we need for now. Let's make our main function, and we can just put return 0 for now. And what we'll do is we will define a class, and this class will be called linked list. So from my drawing, what composes a linked list is basically a grouping of nodes. So we would call these linked nodes. And I don't think I went over this, but a struct in C++ is basically the same thing as a class. So it can have member variables and also member functions or methods. But I think by default, everything in a struct is private, while by default, all the member variables in a class are public. But I think just generally people use structs to kind of store data. And in this case, I think a struct is what makes sense for us to store our list nodes or define our list nodes. because we don't want these list nodes to be directly editable by the user, but they will be edited by the class LinkedList. So not sure if that made sense, but we'll call this struct a list node. I think we need a semicolon here. And I forgot, we will also make this struct private within our linked list class because the users will not be editing these nodes. And then we will have some public methods or objects, I guess, within this linked list class. We'll need a constructor, I believe. So the name of the constructor will match the name of the class. So it'll be linked list. It can take an input optionally, and it will do something. We can define these later. What else does a linked list have? So a linked list should have I believe it should have a pointer to its head node. So we can define that here as a private member variable, and we'll call it. It should be a pointer to a list node, which is empty for now. So we will call it a list node pointer, and we'll call it head pointer. And I believe we should initialize it to null pointer so that we don't, let's see, we don't want to, we want this initialized to something so that we don't pull like a protected memory address. List node is undefined. Okay, so I think we need to move this down below our definition of the list node struct. And auto format. Okay. So this is looking good so far. And I guess we can define what goes inside of our list node. So if you remember my drawing, each node should have two variables that it stores. The first will be the value of the node that we're storing, which is our data. So we can call this, I guess we can make this linked list just a list of integers. So that might be the simplest thing to do. So we can call our value, we can call it value. And then the second thing a node should store is a pointer to the next node. And that will look like another node pointer. And we will call it next pointer, I guess. And again, we should initialize this pointer to null pointer so that we don't have any undefined behavior, which I went over in one of my last videos. Okay, so I think this is looking good so far. And let me think about what to do next. So we have a constructor down here. We're calling this our head pointer. Okay. I guess for the interface, so this under the public interface, which is how people are going to be using this data structure, we want to have a couple of methods. And I think for now, the easiest method we can define would be, I guess we can call it append left. That's kind of how it's used in Python with double-ended queues. So this method will be how we add data to our list, and this will be adding it to the head side, I guess. So that's one method, and then we can also define a method to print the values within our list. Yeah, that's looking good. So when we want to append left, we want to take in a value from the user so that we know what we're inputting. So this value will be an integer. So we can say int val. And within this method, we will, I'll talk about what we do later, but yeah, we'll be taking in a value. And since we're using integers, we don't need to pass it as reference because it's probably more efficient to just take a copy of the value. And our print function will also take in nothing, and then it will do something to print out the values to the console. All right, so what else do I need to do? Let me think about the usage. So let's say in our main function, if we're going to define a list or create a list, we would probably say we would use our class. It would be called LinkedList, and we would call it list. So that's how you define it. And then I would want to do something like list append left some values. So we can do this maybe a couple times. We can append 10 and then append 15 and then maybe 5. So what's happening is at this point, the list will look like a value 10 pointing to none or null. We can call it null. And then since we're appending to the left again, this should now be the new head pointing to the previous head, which is also pointing to null. And then same thing, we'll have a new head, which is 5, which will point to the old head, which was 15, then 10, and then null. So this is, I think, my expected behavior. Let's see, maybe I should just implement the append left function. So let's think about what happens here. So in the beginning, our list is actually going to be empty, and our head pointer is going to be null because that's what we're setting it to here. So what we want to do is we want to create a new node, a new list node, set its value to 10, and then set its next pointer to be our previous head pointer, basically, because our previous head pointer was pointing to null. So I think that's maybe 3 steps or something like that. So we can say list node, and I think we're going to want to be doing this on the heap. So we want to do new node pointer equals new list node. Okay, and then I think I need to define a constructor for our list node. But we'll be passing in a value, so it'll be an integer value, I believe. Okay, so yeah, I think I need to define the constructor for our list node. Let's see. So under these variables, we can define the constructor, which again will be the same name as the struct, and it will take in some values, and the value will be an integer value, and it will also be a pointer, which will be an integer pointer next. And I think we will use our member initialization list, which is another thing I talked about in a previous video. And let's see what we want to do. We want to set, obviously we want to set value equal to val. And we want to set next pointer equal to the pointer that we pass in. Let's see, something's wrong here. Int star cannot be used to initialize an entity of list node. Star. So next pointer is our list node. So I think it's because we have next pointer as type list node star. So I guess this should be actually list node star. Yeah. And that fixes that. Okay. So that's basically all that's happening here is that this is our constructor. So when we're creating a list node, we're passing in a value and a pointer to the next node. Yes, I believe that's correct. Okay. So down back in our append left function, we are passing in a value. And since this is the first node that we're creating, let me think about this. I think we're passing in null as the next. I'm a little confused right now. Null pointer. Let's see what happens here. So list node star. So this is returning a pointer to a new node. So we're creating a new list node on the heap. We are using a value. We're passing in a value. And we're also passing in a null pointer. Oh, I think the problem is I just put these brackets here. I don't know why I did that. We can just put a semicolon. Wait, why is this not working? We are creating a new list node on the heap using new list node. That's the constructor for list node. Type name is not allowed. Int val. Oh yeah, we're passing in our value. We're not, yeah. I thought this was a function declaration for some reason. Okay, we're passing in our value when we call this method. We are setting its next to null. And then what we want to do is we have created a new node and we have a pointer to it. So we want to set our current head's pointer to the to point to this new node that we created. So we will say head pointer equals new node pointer. Nope, I'm wrong. Sorry, I'm confusing myself. So we don't want to do this. We want to set our new node, our new node's next value. So that's the way, this is the way that we access the next value. Since this is a pointer, we're using this arrow operator to both dereference this so that we get the actual node object, and then we can access its next member variable like this. And we'll set the next equal to our current head pointer. And then we want to set head pointer to our new node pointer. List node has no, oh yeah, we want to set it to next pointer. Okay, I think this is correct. So that was confusing, but what are we doing when we append left? We're basically saying at this state, this is our current list and this is our current head. So we're going to create a new node with, let's say we're looking at this line. We're going to create a new node with value 15. That's what we're doing here. And we're going to set this new node's next value to be the current head, which was 10. So 15 will now point at 10. So that's correct. And then our head pointer, which is our new head, will set to this new node 15, which is our new head. So this looks correct to me. All right, that was confusing, but let's go on to print. So for print, the behavior I want is we want to basically print it out looking like this, the entire list. And so the way we do that is, since we only have a reference to the current head, we can say, let's say list node pointer, head pointer, or let's say current pointer will equal our head pointer. That's so that we don't overwrite the head. And then we will need to use a while loop. And what we're going to do is we're going to say while cur does not equal null pointer, we will print out the value of the current node. So that will be cur value. Maybe that's not correct. Oh, I just called it value. Okay. Value. And then we can just print the arrow with some spaces in between. I think that's good for that. And then what we need to do is set our current pointer to be the value of the next, or I guess we'll set it to the next pointer. Okay, so what did I just do here? Basically, what we're doing is we are iterating through the list using this while loop. We're starting at the head of the list. So let's look at this example. When the list looks like this, we're starting at the head, 5. And the reason why we say while cur is not equal to null is because that's our termination, which is when we found the end of the list, basically. So when current becomes null, that's when we'll break out of the loop. But while current is not null, we will print out the value of the current node, which will be 5, plus a space, an arrow, and a space, which will look like this. And then what we're doing here is we're setting our current node that we're looking at to be the next node in the list. So basically, this current variable will look at the new node 15. And that will continue until we reach the end of the list. And when we break out of this, I believe we need to also print, we can just print the words null and maybe put a new line there. So I think that should work. Now let me take another look at this. We're not doing anything in our constructor here. So I'm not even sure that if we need it, but I'm not sure what the best practice is. But I think we should have a good implementation of linked list here. There's one thing that we're not doing, which is freeing the memory that we're using for storing these nodes on the heap, which is when we do this here. So we do need to create a destructor method in our list node struct, I believe. But let me let's test this out and see if this compiles. So we can do G++ linked list, call the output linked list, and let's see what happens when we run it. Nothing happens. That's because I am not calling the print function. So let's call it here, list.print. Compile it. Let's just run it right away. Beautiful. So it works first try, actually. So 5, 15, 10, and null. That's exactly what we expected. Awesome. So I think this is a almost complete implementation of a linked list. But like I mentioned, we are not, this would actually result in a memory leak if we were to use this with a lot of data. The reason is we are storing all of these list nodes on the heap when we're doing this part here. So every time we create a new node, it's actually being allocating memory on the heap, and that node data is being stored on the heap. When we're initializing or declaring this list here, this list variable gets created on the stack, but all of these append methods are using memory on the heap. So I think the way to do that, to fix this, is we need a destructor. And let me think about how we want to do that. So basically, when we are finished using our linked list, or basically like when whatever function context is complete, when we want to pop the list off the stack, we need a way to free that heap memory. So the way to do that is we create a destructor method for our linked list. And the syntax for that is this tilde or squiggly and the same name as your constructor. And then we need to provide some instructions to free the heap memory. So we can do this recursively or iteratively, but I think for me, iterative is more straightforward. And it's basically going to be similar to our print function. And we're going to basically use we're going to call a list node pointer cur and set it equal to the current head. And we can say while cur doesn't equal null pointer, we will basically just delete cur. So this delete keyword is the way that you can free the heap from the memory that is being allocated to this, whatever is pointed to by this pointer. And then finally, we need to update cur again so that we're looking at the next item in the list. Sorry, next pointer, bad naming. I think this should do it. Let's see. So yeah, basically when cur equals null, we'll just, we don't need a free null because that's just a null pointer. So we'll break out of this once we hit the end of the list. And I believe this should solve our memory leak problem. Actually, I am back. I just made a mistake, caught a mistake. What we're doing here is actually bad because we are deleting cur and then we're trying to reset cur to be next. So what we actually need to do is store the pointer to the next node in a variable. Next node equals cur.next. And then what we do at the end is we'll set cur equal to next node, I believe. And I always forget the pointer here. So that way we're not wiping out our current node that we're deleting in this step, basically. And let me show you guys how I use AI to basically just kind of proofread my code. It's just a simple prompt. I will literally just copy and paste the entire file, and I will paste it in, and I'll say, is this a proper implementation of a linked list? And we'll see what it says. So it says, for a basic functional demonstration of a singly linked list, your code is solid. It's clean and avoids the dangling pointer pitfalls and correctly manages memory. To move from a working script to a proper implementation, there's a few standards and gotchas that you should consider. So number one, in C++, if you define a custom destructor, you almost always need a copy constructor and a copy assignment operator. So currently, if you do this, create a list called list1 and append left, list2 equals list1, both lists will point to the same memory. So when the program ends, both destructors will try to delete the same pointers, causing a double free crash. Okay, so that makes sense to me. I guess this is an issue when you're trying to copy data. So I guess that's a minor detail, but this is an improvement that is necessary for production code, basically. We need to worry about that. Number two, the constructor takes a next pointer, but in append left, you pass null pointer and then manually reassign it. So we can streamline this. So what line is this talking about? Append left down here. Head pointer. Head pointer equals new list node value head pointer. Okay. I think this is basically a shorthand way of what we're already doing. You might argue that this is better readability wise since you can see the individual steps. But that could be up to personal preference, I guess. Unless I'm missing some other performance optimization there. Const. Your print method doesn't modify the list, so it should be marked as const, so it can be called on const linked list objects. Okay, so this is a good point, I guess. We can use this const keyword to tell the compiler and the reader, I guess, that this method doesn't modify our list data at all. It's just a read-only type of function. Number three, missing essential features. A proper library grade linked list includes a tail pointer, so that makes append right a constant time operation. Yeah, that makes sense. Otherwise, we need to basically iterate through the whole list to append to the right. We also are not keeping track of size. Good point. And templates. Yeah, this only works for integers. So we would need to use templating to make it work for any data type. Okay, so these are some, I guess, more advanced implementation details that I'm not going to worry about right now. But I think for now, I think it's super cool that we were able to do this. Yeah, we basically used all of the stuff that we've been learning so far. A little bit of some while loops, defining variables and pointers, correctly managing our memory here with our destructor. And it seems like everything works. So let's try it one more time. Maybe we can add some more elements to our list, like a big number here. We can recompile and run and see that it still works fine. All right. Thanks everyone for joining, and we'll see you next video.